In this gas law problem, we're trying to find the volume. It's occupied by 32.0 grams of oxygen gas, and it's at STP. What we need to realize is STP, that's standard temperature and pressure. So the temperature is going to be 273.15 Kelvin, and the pressure, that's going to be at 1 atm. So we have that information. Since we have grams, I know I can get grams to moles. I have moles right here in the ideal gas law. I'm thinking it might be the ideal gas law. Do I have an initial and final set of conditions? No, I do not. So this is going to have to be the ideal gas law. So let's do it. Let's first convert these grams of O2 to moles. Grams to moles, you divide by the molar mass. For oxygen, that's 32, and the units are grams per mole. So now I've got grams up here and here, they cancel out. When I do the math, I end up with 1.0 moles. So now we have N, we have our moles, 1.0 moles. And for R, because we have atmospheres, or we chose atmospheres for standard pressure, we can use this R right here. It has atmospheres right in the units. We also need to look at our temperature. That's in Kelvin. We're good there. We have moles. And our final volume, it's going to be in liters. So let's put everything into the equation. And now to get volume by itself, I'm going to divide both sides by 1.0 atm. So this same on the top and bottom, that's gone. And if you look at the units, we have moles here and moles here. They cancel out. Kelvin, Kelvin, and then we have atmospheres up here and here. That cancels out. So you can see why our units are going to end up in liters. So we multiply, divide by the 1.0, volume ends up 22.4 liters. So if we have 1 mole of an ideal gas or close to ideal gas at standard temperature and pressure, it's going to be 22.4 liters, called the molar volume. So you may have seen this 22.4 number come up when you're converting from moles of an ideal gas to liters. You can do the conversion fairly quickly. That's it. This is Dr. B, and thanks for watching.